All right, let's talk about something that's all around us, but pretty much invisible. It's a system that is absolutely fundamental to all life on this planet. And no, I'm not talking about the water cycle or even the carbon cycle. I'm talking about the nitrogen cycle, the quiet, powerful engine that makes life possible. And we've broken it.
And that's not just some abstract science question, right? It's one of the biggest challenges we're facing today. So in this explainer, we're going to break it all down. We'll look at how this almost perfect system is supposed to work, how we've thrown it completely out of whack, and most importantly, what we can actually do to start fixing it.
So, first things first. Before we can really get into what went wrong, we need to understand the original design. How did nature create this incredible system that worked flawlessly for millions of years?
So at its heart, the nitrogen cycle is basically nature's ultimate recycling program. About 78% of the air we breathe is nitrogen, but for plants and animals, it's totally unusable in that form. The cycle's job is to grab that nitrogen out of the air and convert it into something plants can actually use to grow. And those plants, well, they're the foundation for pretty much every food chain on Earth.
Just think of it as this beautiful self-regulating loop. Nitrogen gets used, it gets returned to the soil and the air when things decompose, and then the whole process starts over again. It's elegant, it's efficient, and it's also incredibly delicate. For a very, very long time, it just worked. And then, well, we came along.
So how did we get to this point? This is where the story really takes a dramatic turn. A whole range of human activities, from growing our food to building our cities, have just systematically overloaded this delicate cycle.
And it really starts with something that seems pretty simple: cutting down forests. When we clear massive areas of trees, we're doing way more than just getting rid of the trees themselves. We're actually attacking the nitrogen cycle right at its foundation.
This slide really shows the domino effect. When you have fewer trees, less nitrogen gets absorbed. Simple as that. But without those trees and their roots holding everything together, all that valuable nitrogen in the soil just washes away into rivers. I mean, in places like the Amazon, river nitrogen has shot up by as much as 50%. This causes something called eutrophication, basically huge explosions of algae that suck all the oxygen out of the water, creating what they call dead zones, where nothing can live.
Okay, next up is maybe the single biggest disruptor of them all: the way we farm. Modern industrial agriculture is basically built on a system that's in direct conflict with the natural nitrogen cycle.
So here's the core of the problem. When we harvest crops, we're literally mining nitrogen from the soil and then shipping it off somewhere else. To make up for that loss, we dump absolutely massive amounts of synthetic fertilizers onto the land. The thing is, plants can't absorb all of it. So where does the extra go? It washes into our rivers and oceans. And the most notorious result of that is the gigantic dead zone that forms in the Gulf of Mexico every single year.
And this isn't just a problem happening out in forests or on farms, it's happening right where most of us live, in our cities and towns. Our modern city life is a huge source of nitrogen pollution. First, you've got sewage. All our waste is full of nitrogen, and it often ends up in rivers. Second, think about stormwater. Every time it rains, all the lawn fertilizer and pet waste on our streets gets washed straight into the local waterways. And third, the emissions from our cars release nitrogen oxides, which don't just pollute the air, they also cause acid rain. It's like a triple threat coming from our urban hubs.
So where does all this extra nitrogen for the fertilizer even come from? Well, the answer lies in one incredible, world-changing invention that turned out to be both a miracle and a curse. The Haber-Bosch process is without a doubt one of the most important inventions of the 20th century. It gave us the power to pull nitrogen gas right out of thin air and turn it into ammonia for fertilizer. It's the reason we can feed billions of people. In fact, get this, it's estimated that half of the nitrogen atoms in your body right now were created through this process. But that miracle came at a truly enormous environmental cost. And this slide lays out that trade-off perfectly. On one hand, yes, we can grow way more food on less land. Amazing. But on the other hand, the process uses a ton of energy, it relies on fossil fuels, and it's the main reason we have all that fertilizer runoff creating those dead zones we just talked about. We essentially solved the problem of global hunger by creating a global pollution crisis.
So with all this extra nitrogen flooding our planet, just how bad is it really? Well, scientists have a way to measure this, and it's called planetary boundaries. Think of them as the safe operating limits for humanity on Earth. And when it comes to nitrogen, we haven't just crossed the line, we've blown right past it.
Scientists have done the math. To keep our planet's system stable and healthy, we should be adding no more than 35 million tons of extra nitrogen into the environment each year. Just remember that number, 35 million.
And this is where we are today. We're currently at 121 million tons a year. That's more than 3 times the safe limit. Before the Industrial Revolution, our impact was basically zero. The scale of this change is it's hard to even wrap your head around.
And this is the bottom line. This isn't some small, manageable problem. Exceeding this boundary by so much threatens the very stability of the global systems that keep us all alive.
Okay, I know, that was a lot of pretty heavy news. But the story does not have to end there. We broke the cycle, which means we have to figure out how to help it heal. And the good news is, we already know how to do it.
The path forward is all about things like regenerative agriculture and just being smarter about how we manage our land. It really boils down to a 4-part strategy that's focused on working with the nitrogen cycle instead of constantly fighting against it.
So, to stop nitrogen from just washing away, farmers can use cover crops. That just means planting something to cover the soil between harvests so it's not left bare. To stop the soil from being totally drained, they can rotate their crops so they're not planting the same thing over and over. To replace nitrogen the natural way, things like composting put all those nutrients right back into the soil. And, beyond the farm, we can tackle pollution by improving our sewage treatment and cutting vehicle emissions, like by switching over to EVs.
But look, at the end of the day, this isn't just a job for farmers or scientists. It's going to take all of us. Governments need to create the right policies, businesses need to innovate, and as consumers, the choices we make about the food we buy can send a really powerful message to the entire system, supporting those who are trying to farm the right way.
And that leaves us with this final big question. We have spent the last 100 years or so overpowering nature's cycles to serve our own needs. The challenge for the next 100 years is going to be whether we can learn to work within them. The health of our planet, and really our own future, completely depends on the answer.